Hello, everybody. Welcome. Welcome to another session of Polkadot Deep Dives. We will be doing the third session here of the learning session of a road to Parachain. And it's going to be, the topic is going to be some more advanced XCM topics, cross-chain topics. We labeled it interoperability and beyond. So we have a lot of good stuff planned for you, and we hope you enjoy it, hope you like it, and we hope you learn something from it. The people who are presenting today will be Hector. Hector is an application engineer at Parity, and myself, I'm a support engineer at Parity. So let's get. If you were keeping up with this is a third road to Parachain session. If you haven't watched the first one, there's a QR code there for you to start with the first one. So I'd say like the prerequisite for the topic today is the first one and the second one. Okay, so the second one, where we left off, if you remember, we left off with opening HRMP channels, and Nacho did a pretty cool test demoing how to open HRMP channels using an integration tool. So that's the prerequisite, the very least. Like, this is a point where it's like, okay, we're a parachain. We've opened up HRMP channels. What can we do now? What are some examples? What are some things that we can do? What should we be mindful of? So the first topic that is important that I would like to discuss is XCM versioning and how XCM versioning works, and take a bit of a deep dive into negotiation, XCM version negotiation. So as we all know, XCM is a language, and it's also a language that changes over time, right? So it evolves. It's a language that evolves. And we've already seen, there was XCM v1, v2, and v3 is already out, right? And so it's going to change, it's going to improve, it's going to evolve. So, and with that, you have the ability for XCM to have a version. You can actually see the Rust code there. You see, like, that's actually pulled right from the source code. That the XCM messages are versioned. You can see v2 and v3. Additionally, the multi-locations can be versioned, and the multi-asset, as well as the associated data types. Right? So everything goes under a version in XCM. And with that in mind, right? So in a world of forkless upgrades and different consensus systems with different versions of XCM, everything is changing. How can we interop safely and effectively, right? So XCM was built with that in mind. XCM has compatibility baked in. And by compatibility, we mean the ability to interop with different consensus systems that have different versions of XCM. So how do we do that, right? One thing to note is that every time we have a new version of XCM, only the previous version is supported. Okay, so for example, if the current version of XCM is v3, then we only support v3 and the previous version, v2, right? We would not support v1 in this example. So that's something important to think about when you're looking at XCM. So another example would be like, before XCM v3 gets upgraded on the relay chain, that means, from the previous example I shared with you, that would mean that all the parachains, if they want to be compatible, they have to upgrade to v2. Okay, so v2 would be the previous version of v3 to maintain that compatibility. And then later, optionally, if the parachain wants, then they can upgrade to v3 as well. So in XCM, there's a concept of backward compatibility. So backward compatibility is the ability of an upgraded system to continue to function in a legacy world. And forward compatibility. So the ability of a legacy system to continue to function in an upgraded world, right? With that in mind, there are limitations. For example, there may be a version of XCM that has features that has like new features that do not exist in the previous version. For example, I believe in V3, there's an instruction called lock asset that just got released with V3, and that doesn't exist in V2, right? It's a completely different instruction that doesn't exist. Or there might be, in the future, there might be a significant feature that is removed from a future version because it makes sense to remove it, and therefore it won't exist in the new version, but it does exist in the previous version. But that being said, the new versions of XCM are designed to be mostly compatible with older and newer versions. And there will be XCM messages which simply don't exist, simply do not make sense to exist in an alternative context and will not be directly translatable. Okay, so we're going to see a diagram later of like that translation. It's also important to note that when you're working with XCM, that it's the responsibility of the sending network to ensure that the message it sends is capable of being interpreted by the receiving network. So as the sender of XCM, that's your responsibility. Don't expect the receiving network to tell you that the XCM message did not work or that it wasn't compatible, the instruction didn't exist, or reply in any type of way. That's not the way that XCM works. The way that XCM works is that you have to know as a sender, it's your responsibility to make sure, like it says, that it's the message that you're sending is being capable of being interpreted by the receiving network. So the version of XCM used for the message must be no newer than the version of XCM that the receiving network supports, right? Otherwise, it would not work. So this is really important to note, this slide here. When we're talking about like versioning within XCM, there's a few instructions that we want to look at. One of them is subscribe version. So subscribe version is an instruction where essentially we're asking the destination what version they support. Okay, and the destination is going to respond with a query response instruction with the version it supports. It is a subscription. We're going to take a look at that more in depth, how that works. But at this point, it's important to just understand that it's an instruction called subscribe version. You can see on the right there that it has a query ID. The query ID is it's a unique identifier for that specific subscribe version. And it's also going to be what ties the query response to that particular subscribe version. So the query response instruction that we're going to receive will ultimately have the query ID of the subscribe version that we sent. And it will additionally, the query response will have the response, which has the XCM version that the destination supports. Okay, so by now you've probably used XCM quite a bit, and you're probably thinking like, I've never had to write a subscribe version instruction before, right? So like, where does this come? So that's true. This all happens under the hood. It's an automatic process of version discovery, you could say. And we're actually going to look at it. It's actually pretty cool. But the idea is that if you look at this diagram, in this example here, we have chain A. Chain A wants to send an XCM message to chain E. So chain A is running, if you look in the registry, it's running V2, right? XCM V2. Chain A has XCM V2. And the first thing that chain A says is, all right, I want to send an XCM message to chain E. Let me check my registry, right? Let me check the registry to see if I have chain E's version in my registry, XCM version. And it just so happens that in this case, we do have it. You can see here chain E, and it's in our registry, we're saying that chain E supports v3. All right. So then what we'll do is, because chain E or chain A is running v2, we would craft a v2 message, XCM message, and we'll send it to chain E. Chain E then receives the v2 message and automatically translates it to v3 prior to interpreting it. All right. So there's other scenarios, like what if we did not know chain E's version? What if it wasn't in our registry, right? What would that look like, right? That's why it's important to understand how the version negotiation process works. So we're going to be looking at those other scenarios. One thing that's also important to note in terms of XCM versioning is the code compatibility. The way that XCM, if you look at the code in the XCM code, you're going to see that it's in modules. So it uses Rust module system. So it's all really nicely encapsulated. You're going to see like there's a module for v2, there's a Rust module for v3. So even the code was structured in a way that had compatibility in mind. When you're upgrading your chain to the next version of XCM, some tips that we suggest is often there's a PR associated with the newer version of XCM. And for example, this here is showing you the PR for XCM v3. And I'm highlighting it here because as a builder in the ecosystem, if you're building a production level parachain, this PR was crucial. It had a lot of documentation on XCM v3 that every builder that's upgrading to v3 should read. And additionally, little things like, for example, this section here, the code migration considerations from v2 to v3, right? So you can see that there's some explanation here. Here's the old code, and then it starts talking about the new code. So certain PRs you want to follow, right? But how can you keep track of? There's a lot of PRs happening in Substrate. There's a lot of PRs happening in the Polkadot repo. How do you know which ones to follow? So there's something called Polkadot release analysis that Parity has been working on, and it's something that I actually think is super useful from a production standpoint if you're building in the ecosystem. And I actually want to show you this. So let me get off here this slide. But essentially what this is it's a release analysis that a team of engineers do for each release that comes out from Polkadot. And we do it from a perspective of the builder's perspective, folks, developers who are building in the Polkadot ecosystem. So this release in specific, I'm highlighting because if you see here, this is the release that XCM v3 came out, right? So if you're following this release analysis, let's look at it. Make it a little bit larger. So this was release 38, right? So if you're following it, you can see that it's condensed, right? So for example, we're noting here XCM v3 came out, and then we're noting certain things that we're kind of highlighting for the ecosystem, what we think is important for you, right? So for example, in this release, we highly encourage you to actually look at the XCM v3 PR. So if we open that PR, you can see that that's the PR, right? And we're encouraging you, okay, here's a good PR because it's a worthwhile read because it talks about XCM v3 in depth, things that you should know, things that you should look out for, okay? The other thing that sometimes you get with these Polkadot releases, if we actually go to the XCM v3 section in this release that we talk about, which is right here, you get a little bit of a summary of that particular feature. All right, and you get a little bit of a description here. And in this one in particular, one of the Parity engineers, they wrote a hackmd that in the context of like, if you're V2 and you're looking to move to V3, things that you should think about. So if we look at that HackMD, you can see there's a lot written in there that could be useful for you as a builder. Okay, so really, really important as a Parachain team to be looking at these Polkadot release analysis. The other thing, as far as like version negotiation, there was this PR from the past here that I want to highlight. This was the PR where automatic version negotiation came out. And it's really interesting because the idea was that we shouldn't have to manually ask these chains, the chains that we want to interop with, we shouldn't have to ask them for their latest XCM version that they support, right? It should be an automatic process. So that's where this PR came in. And this was built. It's built into the system. So the idea is that there's different scenarios, like 3 scenarios here, right? So say we want to send an XCM message. And the first thing that we do is we want to send an XCM message to another system. So the first question is, do we have a supported version for a supported XCM version for the destination? Do we know the destination's supported XCM version? If we do, if it's in our registry, then great, that's awesome. Let's send the XCM message with that XCM version that they support. All right, that's like probably the easiest scenario. However, in the beginning, that registry may not be populated because this may be the first XCM message, the first use case where we're interoperating with this change, with this chain, right? The destination chain. So if that's the case, there's 2 potential scenarios here. If we don't know the destination's XCM version, this is where that automatic version discovery process would kick off in the background. All right. And in the meantime, while that kicks off, while that runs in the background, it'll run on the onInitialize of this chain here in the onInitialize hook. While that version discovery is happening, we will send the XCM message with what we deem as what we set as a safe XCM version. All right. So on our chain here, the one that's sending the XCM, we have a safe XCM version that we kind of hard code in there. We can change it at any time, but it's there. And that's the version of XCM. So the issue with this scenario here, with sending the XCM message with a safe XCM version, is it may work or it may not work, right? And if you remember that slide that I shared with you a while back where it was like, it's your responsibility as the sender to make sure that the instruction works, right? Don't expect the receiver to say, hey, this didn't work for whatever reason, XYZ, right? So this may work. The safe XCM version that we send, it's like, okay, that may be the latest XCM version that they support. That's great. Therefore, it works. Or maybe the safe XCM version that we use to send isn't the XCM version that they support, and therefore this instruction would not work, right? And then eventually, after this onInitialize hook kicks off, and eventually we're going to get back the XCM version that destination chain supports, and it'll be in our registry, so that then in the future, when we want to craft additional XCM messages, we know that the destination's XCM version, and we can send it with the appropriate XCM version, right? So you could say that's the lazy scenario where it's like, hey, let's just send it with the safe XCM version until we know their actual XCM version that they support. Another scenario, if we don't know the latest XCM version that they support, is to use the extrinsic. There's an extrinsic called force XCM version, and we pass it in the destination and the XCM version that we want to send the XCM message in. to the destination, right? So you could think of this as more of like a proactive scenario of like, maybe I'm chain A and I want to communicate with chain B. And as a developer, I know that chain B is running XCM v2, right? I looked in their storage, right? So then I would call an extrinsic force XCM version, the destination's multi-location, and XCM v2. And boom, the XCM message is now going to be sent with v2, and it succeeds. All right. So that's a good, I would say that's a good use case if it's your first time interacting with that chain. And then of course it'll get populated. The supported version of that chain will get populated into our registry. Another thing to know about this automatic version discovery process is that when we do version upgrades, XCM version upgrades, because this is a subscription, and any subscriptions that we have live with other chains, if other chains upgrade their version of XCM, we will be notified of those upgrades, and it'll be updated in our registry. Okay, so that's really useful. So what I want to do next is kind of like walk you through this process that I described here, right? So let me share my code here. So the first section, this is the Polkadot repo here. The first section was when we send an XCM message, we wrap it with an XCM version, right? And this is here in the code here. This is where it's happening, right here. So wrap version. Okay, so right there, the function wrap version. If we look at it, right, the first thing that it checks is the destination's chain XCM version, the latest version that chain supports, is that in our registry, right? In this case, our registry is supported version, the storage supported version, right? If it is, then that's great. Then let's wrap the version of XCM that chain supports and send the XCM, right? If it isn't, that's where we get into this function here called note unknown version. So we're going to note that, hey, we don't know the destination's chain's version. And that's going to kick off this function here called note unknown version. And you can see what this function does. It adds that destination chain to this version discovery queue. Okay, so we're going to queue it up. We're going to say, hey, we don't know this chain that we want to interop with. We don't know their latest supported XCM version. So let's add it to this queue. And if we had already requested the XCM version of this chain, then let's just bump the count and say, hey, this is like the second time that I'm asking for their latest supported XCM version. So I'm going to bump the count, indicating that like this is a chain that I really want to know their XCM version. If it's the first time, then we'll just add it to the queue, add that chain to the queue, and just give it the number 1, right? It's the first time. So where this version discovery queue really comes into place is in the onInitialize hook. Right here in this onInitialize hook, right? We're in the palette XCM, by the way. Two things happen in this onInitialize hook. So this is onInitialize, right? It happens at the beginning of every block. And this is from the perspective of the sender, right? The one that's sending the XCM. So two things happen here. One is you can see that if there's a migration, right? A migration is happening. And one thing that I get asked, I've gotten asked quite a bit is like, how do you do multi-block migrations? In this palette, this is a great example of a multi-block migration. Okay, so the first thing that you're going to see here is if there's a migration, the migration is happening. The second thing that you're going to see in this hook is the version discovery queue. that we just talked about, right? So we're going to grab the location that's in the version discovery queue, and we're going to call request version notify. So if we look at request version notify, so requests that the destination informs us of its version, right? So at the beginning of every block, the onInitialize is going to do any migrations if there are any, and it's going to then check the queue, the version discovery queue, and it's going to request that the how do you say, the chain that has, remember how we were incrementing the counter, the chain in there that has the most numbers, right? If it's been requested, like I want to know this chain's version like 5 times, and the other ones that we want to know the version is like 3 times or 1 time, then the one with 5 is going to be the first one that we're going to use request version notify with. And if you look inside this function, it's first going to check that the destination hasn't already been requested. Okay, that's the check that's happening here in version notifiers. We're going to check if it's already in the version notifiers. If it's not, then we're going to proceed to create the instruction subscribe version. So this is where subscribe version comes in. And this is where we're, as the sender, we're creating the subscribe version instruction. And we're actually, if you look here, we're actually sending the XCM subscribe version instruction right there. Right? So we're sending it to the chain that we want to know their version. We're saying, hey, I'm sending you a subscribe version instruction. And so that gets sent as an XCM message to the chain. And then from that point, the chain that will receive that instruction, right, will be the other chain, the receiver, you could say, right? The receiving chain will receive that instruction, and it will actually process it in the receiving chain's XCM executor, right? So they'll have an XCM executor like this. This is the XCM executor file. This will be happening on the receiving chain. And you can see the subscribe version instruction, what it does. Right here, this is the line that I want to highlight. Config subscription service start. Okay, so in the config of that chain, that receiving chain, we set a subscription service, right? And just to show you an example of that, I have a parachain here. I have a Trappist, right? It's a showcase chain that we've developed here at Parity that showcases a lot of XCM examples. Here it is. And what I'm showing you here is the XCM config of Trappist. Okay, and right here, you can see subscription service. And what we're assigning subscription service is Polkadot XCM, right? What is Polkadot XCM? Just to reiterate, Polkadot XCM is, if you look at the runtime of Trappist, Polkadot, this is the construct runtime here. So all the pallets, Polkadot XCM right there, right? So what is Polkadot XCM? Polkadot XCM is pallet XCM on the parachain, right? And that's what we were looking at. So if we look, so just to say it again, our subscription service is actually pallet XCM. So if we go back to pallet XCM here, because that's the crate, right? The pallet XCM crate. So you can see we're going to kick off pallet XCM's start. So if we look at, actually, if we go back to pallet XCM, we search for start, you're going to see the start right here, and it's the version change notifier. So if we just to go back to Trappist one more time, subscription service, I think I have it here. Yeah. The type for subscription service is the trait version change notifier. Okay, so we're implementing that in pallet XCM right here, version change notifier. We're defining here start, what it does. Okay. So remember, this is the receiving chain, right? This is going to be happening on the receiving chain. The receiving chain is going to get a subscribe version instruction. It's going to call config subscription service start, which is defined inside of palette XCM here, or it's being implemented here. And what does that do? Well, one of the things it does is it checks, right here it says the target locations that are subscribed to our version changes, as well as the most recent changes of our versions we inform them of. So it checks if we've already informed the subscribers, if we already informed them. If we haven't, right, that's where we're checking here. As long as we haven't, then continue here. And actually, we're saying here, we're grabbing from advertised XCM version. So advertised XCM version is the latest supported version that we advertise, so that the receiving chain advertises. And it's generally set to palette XCM current XCM version. Okay. So we're grabbing the latest XCM version that we advertise, and we're actually going to craft a response, a query response instruction with the latest XCM message that we as the receiving chain will advertise. And we're going to send that XCM message right there. Okay, so we're sending that instruction back. We're going to send it back to the sender, right? So we're the receiver here. We're going to send it back to the sender. We're going to say, hey, this is the XCM version that I support, right? And then here we're going to actually add the subscriber to the list of subscribers inside this version notified target. So they're now in the list of subscribers that we've notified. And one thing to note here too is when we send this XCM with the query response, right, we're the receiving chain here, and we send it back to the subscriber, to the sending chain. The sending chain will actually interpret this query response here in the on response handler. So that's probably like the last piece here. So if we look at the on response handler, specifically on response, the first thing that we do is we do some checks to make sure that the response is a response that we expect. But the most important piece here, I would say, is right here. Right there. We're inserting, we got the response from the chain, and the chain saying, hey, this is the latest XCM version that I support. That's awesome. We interpret the query response on our XCM executor, and we insert that version of XCM into supported version storage. So we now have that chain's supported version of XCM in our registry, right? And that, just to recap, that happened all under the hood, right? Automatic version discovery process. All right. So just wanted to show you that. I thought that would be a pretty cool walkthrough. What else? Let's see. So I also included in the slide here, like if you want to do this yourself, this is like kind of like the walkthrough that I did, search for these functions, and you can, it helps you to understand how the version negotiation happens under the hood. The other thing that I want to kind of highlight, right, because we're talking about building parachains and production scenarios and things like that. I just want to remind that we do have a support community, right? It's called Stack Exchange Substrate and Polkadot Stack Exchange. And it's a community-led, you could say, like technical support website. And I encourage you all to participate. So I'm just highlighting here on the slide one example of an interesting XCM question that was asked. And it just so happens that the person that answered this was one of the lead developers on XCM. So you get that type of interaction on Substrate Stack Exchange, and we'd love to see more interactions like this happening because it helps everyone in the community. Some resources, if you haven't, please read the XCM blog that Gav wrote on versioning. That's really helpful. And there's also a deep dive on XCM, and there's a specific, this link here, if you go to this link, I'm actually linking you directly to the point where it talks a little bit more about subscription service. So if you want to know a little bit more or want to hear it from a different context, that's a good deep dive on there. So let's switch gears a little bit. I want to talk a little bit now about cross-chain assets and asset registry, right? So once you've opened your HRMP channels, let's say between two parachains, parachain X and parachain Y, a good next step is to register your chain's asset on the other parachain and vice versa. That's a good, it's a good next step. It's also a good exercise. So something like this. You can see there's parachain X on the left and parachain Y. So parachain X has, actually that's supposed to be XUSD. So parachain X has an asset called XUSD, and it's going to, parachain Y is going to register XUSD from parachain X on parachain Y. The thing here is that you can see here, you're noting here the parachain IDs and the pallet instance, right? So in this case, it'd be whatever index of the pallet is pallet 50, which would be pallet assets in this case. So pallet assets on this runtime here is in index 50, okay? And then the general index of that asset on this chain here. So 50 actually, I'm sorry, I misspoke that. It's the pallet instance on parachain X, right? So it's going to be 50 on parachain X. All right, so this is a good next step. If you want to know how to do this, there's actually, I'm going to share with you. Let me get off here because it's also a good place to share. Like, as a parachain builder, this is a community, right? Polkadot is a community, and there's a lot of initiatives happening in the community, and there's articles being written by the community. There's tutorials being written by the community. There's discussions happening on Polkadot forum. Like actually the Polkadot release analysis that we launch, it's on the Polkadot forum. All right. So we actually encourage you, like there's a really interesting Polkadot forum article happening right now on the concept of a global asset registry, right? And there's a discussion, you can see the discussion happening, and for you can all partake in that discussion, right? And decisions are being made and things are changing, right? So we invite you all to just participate in the Polkadot forum. But what I want to show you is a tutorial that part of the community wrote on creating, doing asset registration, like I just showed you in that slide, between two parachains. So here's an example of asset registrations that you can do on a Kusama parachain. Once you have your chain in production on Kusama, you can register it with the parachain Calamari, right? And they wrote a nice tutorial on that, how to do that. But what I want to highlight is that it's not only production here, right? Anything that we do in production, we always want to test it before in two places that I would recommend. And that's why I want to highlight this article as well, because they actually give you a step-by-step guide on how to do this on Rococo, right? So Rococo is a great test network for XCM. It's a great test network for interoperability. So if you're a parachain in production in Kusama or Polkadot, right, then we definitely hope that you're testing cross-chain interoperability scenarios on Rococo. All right, it was built with that in mind. But also a layer before that is you want to test this locally as well, right? You want to test this. You want to spin up a relay chain on your machine and have two parachains running locally on your machine and test it even before you go in Rococo. All right. So that's what I wanted to cover here with my portion. Next, I'm going to hand it off to Hector to go a little bit deeper into um, the idea of cross-chain assets and in combination with interoperability between common good parachains.
Perfect. Thank you, Bruno. That was an excellent introduction and very informative and with very deep information. What I will do right now is to just combine some demo and some walkthrough to basically show like how this negotiation versioning is happening, right, on a local network. And also I will implement, or we are going to review like an example of how to apply this or implement this asset registry on your parachain. And basically for doing this, we are going to use Trappist, which is like this internal parachain like we are developing in delivery services, which is a non-production parachain that basically we use for experimenting like advanced XCM scenarios, let's say. Okay, so basically the topology that we are going to use right now is like we are going to use Rococo as the relay chain that you can see on the tabs, which is on the red color with the red color group. We are going to use a StateMine, which is our common good parachain for assets. We are going to use Trappist. Okay, so basically what we are going to do in this presentation in particular, we are going to run XCMB free already for Rococo and for StateMine, but Trappist will remain on version 2. So we are going to test here how all this conversion will basically happen, okay? And as well, we are going to register, okay, the asset which is defined on StateMine, and we are going to register it on Trappist. So basically, when the asset that will be transferred from StateMine into Trappist arrives, Trappist knows how to basically convert that, or how to basically translate, that minting instruction based on what it was defined on the asset registry. So if we do like, let's say, a follow-up from the previous versions, I want to basically show here that the HRMP channels for all the chains are already opened, okay? So something to basically let you know is like this parachain will not be used, so we will use like only these three. StateMine, of course, is the ID 1000 and Trappist is 2000. So if we see here, we can see like the HRMP channels are already open. And remember, like the channel is unidirectional only, right? So you will have like, for example, this channel, which is the one that used from StateMine to Trappist, and the other way around, which is here, okay? That's for doing like a follow-up on the previous learning session. Also, what I wanted to show you is like on StateMine, I'm basically, if I query the storage of the Polkadot XCM palette, okay, of the palette XCM, I have this safe XCM version, which is running version 3. If I go to Trappist, you will see like this a safe XCM version shows, okay, like the version is 2. But something interesting that basically you can do is like you can review which versions are being set up from your chain, okay, as the result of this negotiation process. Basically, I'm on StateMine right now, okay, and if you do the query for supported versions using the palette XCM, and you set here your current XCM version that your chain is running, you will be able to see here, okay, which versions are being set up for this specific chain to connect or to send message to the destination. In here, what we are basically saying is like these multi-locations, which is the relay chain, is basically set up to be communicated through XCM with the version 3. But this is the interesting input, in my opinion. Basically, what I'm saying here is like a StayMine, which is running the version 3 of XCM, related to, for communicating with XCM with the Parachain 2000. This is the multi-location for a Trappist, which is the Parachain ID 2000. It will use the version 2, okay? This basically happens as the result of a negotiation process that we talked about, all right? In case like you want or you need to force a specific version for the destination because you agree that with the destination parachain, you basically can use this force XCM version, which is the one that Bruno spoke about, okay? And basically you need to define the multi-location for the parachain and the XCM version that you want to use here. So for example, I have executed this already on StayMine. So I have like the example. And basically what happens is like you will basically receive this support version change where it says, okay, good. So for communicating with this Parachain 2000, which is Trappist, I will set the version 2, okay? And also at the end, I will basically restart this local network that I'm simulating here. And I will show you like how, for example, when the relay chain gets communicated with StayMine, it will do all this negotiation process automatically, okay? But let's go through the code a little bit, all right? And basically, what I want to show you right here is like we have an example of an asset registry palette where we basically are like exposing this register reserve asset extrinsic. And once you basically have like all the checks, okay, that the asset exists and or it was not already registered, basically it's just inserting the asset ID and the multi-location that will match the remote, or let's say like the external asset, the remote asset, okay, with my local asset. So basically what we need to do is to match and says, okay, I have this asset ID on my chain. And basically every time like I receive an asset from a remote, let's say, or an external parachain, I want to match it with this asset ID. So basically this is what the palette is doing, okay? But just creating the palette is not enough, okay? Basically, you need to implement some, let's say, some primitives, XCM primitives, which implements a specific traits that will be used then on the XCM configuration, right? So for example, this assets multi-location implements, okay, this convert trait, which is the one that XCM automatically behind the scenes, the pilot will use and will know basically which implementation to use for executing this convert ref or this reserve ref, okay? Basically, this convert ref is when there is an incoming message or an incoming asset. So I say, okay, I get the asset ID for my current chain. If I want to send an asset to another parachain, basically the reserved ref is going to be used and it will basically query the multi-location, right? Because remember, for basically linking or referring to an external or a remote asset, I will need to use multi-locations, okay? So in our XCM config, we have this we have this concept of asset transactors. All right, basically an asset transactor is a type that says to your chain how to basically handle your local assets when there is an XCM interaction. All right, So I will not go through in depth with the asset transactor because this was covered in previous learning sessions. For example, I recommend you to go to the one that Bernardo did about like XCM config. You will see all the details for the asset transactors, okay? But there are like interesting intakes from here. Like, how do I, for example, implement my asset registry, okay, for my XCM config of my parachain? And basically what you need to do, okay, is first of all, you are going to define your fungible adapter that will be set on the asset transactor. And basically, on the fungible adapter trait that you will implement, the second argument is this converted registered asset ID. And the third basically type that is going to be provided to this converted registered asset ID, which also we have implemented as well, we have defined as well, okay, as part of our primitives that we need to implement. What we are going to set in the third type of an input or argument, let's say, is the asset multi-location primitive that we have defined. And we are going to provide the asset ID, which is the type for asset ID, which this is like the common one, like or the general one that we use in our runtime. And the asset registry is the palette instance of we have like basically set up. All right. So on your fungibles adapter, the second type argument, basically you need to provide this converted register asset ID, which implements the matches fungible. This is where all the magic is happening, where it says, okay, this multi-location with this asset ID, but also within this type, you will need to provide this as asset multi-location, where you will have the convert ref and the reverse ref. Okay, so this is basically how it is set up. Then, as a result of this fungible adapter type that you will basically set as the reserve fungible transactor, you set it on your asset transactor tuple. Okay, and then yeah, this is going to be basically provided on your asset transactor, and that's how basically this is going to work. Okay, so if we go to like a more practical example right now, we are going to go on Tropist. Okay, and before doing that, what I want to show you is like we have an asset, which is the asset ID one on Tropist, which is WUSD. Okay, and there is no minting, of course. There is no supply at the moment. It's just the asset which was created. And then what I want to show you on StayMind is like we have STUSD, which has a supply. Okay, this one has a supply mint already. And what we are going to do before, like if I send, you know, a transfer from StayMind to Tropist, Tropist will not know. Basically, Tropist will not count with the information to know how to basically translate that message that is coming. So basically, that's why we use the asset registry. And if you remembered, okay, on the asset registry, we have this extrinsic, like we have defined as register reserve asset. And this is exactly what we are going to call. Okay, so the first argument is an asset ID. In this case, we are going to say, okay, we are going to map our local asset, which is the asset ID one. Okay, and we are going to map it with, okay, a remote asset, which is defined on the Parachain 1000, which is a StayMind, which is defined through the pilot instance, which is number 50. Okay, basically on StayMind, the pilot instance is the number or the ID 50, and the general index is basically the ID of the assets. Okay, if you remember what Bruno presented in his like basically draw, you remember like there were the two parachains, okay, defined, and there was the asset ID one, and on the right side there was like the multi-location for the remote asset, let's say. And this is what we are going to basically register right now. And of course, we need to use sudo, right, which basically use root access. And the reason for this is like, yeah, we want to basically restrict the access of this registration. So let's wait until this is done. Okay, good. So here we got the asset register already. And for the record, I tried transferring the asset before without this asset registry set up. And this is basically what you receive, okay? Failure to transfer asset. It doesn't know what to do, okay? Well, now what I want to do is to basically send the reserved transfer asset, okay, from StateMine into Trappist. We are going to basically make use of all what we have described before. So let's wait until this is done. Okay, we have attempt. Okay, and we see that the asset has been issued. All right, everything has worked as expected. But I wanted to show you something, and I don't know if you have like paid attention to it, but we are using a multi-location, which is the version 3, okay? And we are using a multi-assets version, which is the version 3 as well. But remember that what we have said is that Trappist is running with XCM version 2. So let me just refresh that. And how is this possible? Well, this is because of the GRUT version that Bruno was talking about and presented before. Basically, here we are exposing like a message, which was a version 3, was correctly converted to version 2. And basically, when that happened, StateMine said, okay, based on the registry of I have, I know that Trappist is working with the version 2, so I need to convert my v3 message into a v2, right? And this is basically the proof that this is working, all right? And what I will do right now is I will basically kill this network. Of course, I'm using Zombienet for doing this, all right? And I basically should receive like a whole new and fresh environment in my local. So let's wait until everything is started. So while we wait until everything is started again, and I'm sorry to be off track. Oh, okay, let me see if I can do it now. And let me see if StateMine is up and running. I need to wait until all the systems are like basically synced and communicated. Okay, my relay chain is producing blocks. StateMine is not yet, it will. Basically, what I do right now is I will just try a teleport on StateMine or from the relay chain. Okay. All right, so I will wait until StateMine will produce blocks. It should be very soon. Okay, yeah, good. So what I will do right now is try teleporting assets from the relay chain to a StateMine. Okay, and what I want to show here is like all the negotiation process that will happen. Okay. So for example, here we says, okay, that relay chain during its first communication with StateMine, it has basically requested StateMine to report what is its XCM version. So this is interesting because a Statemine basically is reporting through this events that says a remote has requested my XCM version. So I basically, someone requested me to subscribe for reporting my XCM version. And basically what happened here is the other way around. It says, okay, I will report, which is my version. So please now you tell me what is your version. Basically, this is a statement speaking with the relay chain. Finally, when the relay chain answers to that request, a statement says, okay, good. That is good to know. Okay. Basically, the relay chain, which is my parent, talking into XCM terms, has the version 3. Okay. And if we go on Staymind to the Polkadot XCM palette, and we basically query, is basically going to say here, okay, me, which is running my version 3, the multi-location, for the multi-location parents ones here, which is the relay chain, I will set the version 3. Okay, so basically here we are showing how like the whole negotiation, automatic negotiation process works. And with this, basically we are done with this. Something I want to also speak about for just giving, you know, additional content and for closing up this learning session series about like how to basically launch your Parachain in production is like, and we are basically in this one, we are talking about like advanced interoperability, okay, concepts. So one thing like is not too much mentioned or discussed in the ecosystem is like basically how smart contracts will use all these interoperability tools that the ecosystem is providing for basically connecting or to make 2D apps based on smart contracts, to speak. So I will not do a demo right now on this, but I will talk about what's the current status in the ecosystem. So, you know, like we have 2 smart contracts works at the moment. One is the one based on ink, right, which would be like basically most of the time, which will be compile and execute using the pallets contract. And the other one is Solidity, okay? Basically, there is a palette which is called Frontier, okay? And that allowed us to basically compile Solidity contracts, okay? So just to give you a very, very quick overview about how this is being handled right now, there is a proof of concept. So please don't take this as production ready because it is not. It's a proof of concept, okay? So in smart contracts, okay, or the pallet contracts specifically, you have something which is called chain extensions. And the chain extensions basically allows you from an ink contract, okay, to communicate with the runtime or the pallets specifically and execute things through there. So there is a proof of concept right here, which is very, very interesting, which basically is defining a chain extension for executing XCM XCM processes, right? So if you implement this chain extension on your pallets contract setup, the contracts running ink will be able to execute XCM instructions. Again, this is like a proof of concept. Basically, the team right now is exploring if using chain extensions is like the best way to do it, or if it's going to change like into another design for executing. But this is something like maybe you can start reviewing if you want to play and make like smart contracts to communicate with XCM. For now, this is not decided if this is going to be like the final way, but this proof of concept was like a very interesting and fun way to see if we can like connect smart contracts running on ink with XCM. And the other side, I basically talk about Solidity, okay, and how basically Solidity can like execute XCM messages. And honestly, that's something like, like how can I say this? By basically, my personal opinion is like basically Moonbeam Parachain is leading the efforts for the Solidities and XCM. Okay, and basically they have developed these X tokens palette that basically allows to send XC20s. All right, and it's like a very interesting implementation, because what this is doing is basically, my understanding is like they are like combining the palette assets with precompiled contracts, and basically that precompiled Solidity contracts allows to have communication with the palette assets. And once you have the assets, the palette assets, or you have like your asset from your Solidity being communicated with the palette assets, then you can like send the XCM, the asset as an XCM asset with no issues. All right. So this is one of the implementations of how Solidity executes XCM messages for sending assets, which in this way, Moonbeam defined it as XC20s. All right. So that's everything what I have to basically share right now.
So hopefully this was fruitful for everybody, and it's like we noted in the very first slide. It's just, there's the beyond, right? Interoperability and beyond. So there's a lot more that we can discuss, and we also plan on sharing with all of you. But this can get you started, right? So thank you all for attending, and yeah, thanks.